Today we are talking about the future of artificial intelligence. I conducted an interesting experiment. I went to Bing, and as we all know, Bing is now completely integrated with OpenAI's ChatGPT. So I went to Bing and I asked it a question. What is quantum computing? Obviously, I didn't do a quick Bing search. I went to chat. And the response that I got from Bing Chat about quantum computing is very interesting. It's interesting not just because it gave me the answers, it gave me the answers in such a way that I could easily understand them. So quantum computing is a process that uses the laws of quantum mechanics to solve problems too complex for traditional computers. Quantum computers rely on qubits to run and solve multidimensional quantum algorithms. Qubits are the basic units of information in quantum computing, similar to bits in classic computing. However, unlike bits, qubits can exist in a superposition of two states, which means they can be in both states at the same time. So, I was a little bit more curious about qubits, so I asked it another question. What is a qubit? A qubit is a basic unit of quantum information that can be in a superposition of two states, usually denoted as 0 and 1. A qubit can be realized by a physical system that has two distinct and measurable states, such as the spin of an electron, the polarization of a photon, or the energy level of an atom. So basically, instead of bits, which is 1 and 0, it can either be 1 or 0. A qubit can be 1 and 0 at the same time. So, it talked about quantum entanglement and what have you, which is basically a concept of quantum physics. So I asked it, what is quantum entanglement? Now, quantum entanglement is a phenomenon that occurs when two or more particles become linked in such a way that their quantum states cannot be described independently, even when they are separated by large distances. This means that measuring one particle's properties, such as its position, momentum, spin, or polarization, will instantly affect the other particle's properties, regardless of how far apart they are. So if you have one particle here and the other particle probably on the other side of the galaxy, if you change something here, the change will be seen over there as well. Now, earlier we used to believe, and Einstein postulated, that light is the fastest thing in the universe. In fact, it is considered to be a universal constant. So even if you are traveling at the speed of light, or probably slightly less than the speed of light, and if you fire a photon in the direction that you are going, the relative speed of light and you would still be constant. It would still be going at the speed of light. So the relative speed of light is constant. And that was the belief, that light is the fastest thing ever, right? There's nothing that can go faster than the speed of light. But if you think about quantum entanglement, if you've got two particles quantum entangled, if you make changes to one particle over here, the other particle will reflect that change even on the other side of the galaxy at the same time. So it's way, way much faster than the speed of light, because light takes about 8 or 9 minutes to arrive from the sun. And here, what we're seeing is the changes happening instantaneously across the galaxy. So that's quantum entanglement. Quantum entanglement is used in quantum computing. So I started getting curious. I wanted to know more. So I asked, how does quantum computing help in progressing artificial intelligence? Because the topic here is not quantum computing, it's artificial intelligence. And the answer that I got is very, very interesting. Quantum computing can help in progressing artificial intelligence by providing a faster, more efficient, and more accurate way of processing and analyzing large and complex data sets. Quantum computing can also enable artificial intelligence to tackle problems that are beyond the reach of classical computing, such as breaking encryption, simulating quantum systems, and optimizing complex functions. Quantum computing uses qubits and so on and so forth, and quantum computing can enhance artificial intelligence by increasing its speed, efficiency, and accuracy. It can utilize qubits and operate non-linearly, outperforming conventional computers and so on and so forth. So basically, it's an extremely fast computer, much more faster than what we have today. Quantum computing and artificial intelligence are both transformational technologies that have the potential to revolutionize the field of science, engineering, and society, and so on and so forth. So then I asked, what are the major challenges in the field of quantum computing? I can understand that quantum computing can revolutionize artificial intelligence, but what I really wanted to know is, where are we when it comes to quantum computing? Are we there yet? Or do we have some major challenges on our path? So the field of quantum computing is a rapidly emerging technology that has many applications and implications for various fields of science and engineering, obviously, and so on and so forth. Some of the major challenges are, first of all, error correction. Quantum computers are extremely sensitive to noise and errors caused by interactions with their environment. So they have to be kept in a very controlled environment, probably in a vacuum, so that it's not impacted by the environment. Scalability. While quantum computers have shown impressive performance in some tasks, they are still relatively small compared to classical computers. Scaling up a quantum computers to hundreds of thousands of qubits while maintaining high levels of coherence and low error rates remains a major challenge. So we still don't have so many computers like mobile phones. Everybody has one at this point in time. They're resilient to the environment. They work in various circumstances. Quantum computers are not like that. They haven't been scaled yet. And then hardware development. Developing in high quality quantum hardware such as qubits and control electronics is a major challenge. Qubits are the basic units of information in quantum computing and so on and so forth. However, each system has its own advantages and disadvantages, such as stability, scalability, and connectivity. Finding the optimal system and material of qubits and designing efficient and robust control circuits are key challenges. So at this point in time, we don't have the necessary hardware, and we haven't still understood the mass production of hardware that's required in quantum computing. Software development. Developing quantum software such as quantum algorithms and programming languages is another major challenge. That's another breakthrough that we are going to need. Quantum algorithms are much more complex than classical algorithms and require developers to approach computational problems in original and creative ways. The next question that I really wanted to ask is, what are the challenges that we are facing when it comes to artificial intelligence? How are we going to go from here? Now, we've made some major progress already. And, if you look at the question answers that we are doing with this artificial intelligence large language model, it's quite impressive. It's being able to explain to me what quantum computing and artificial intelligence is. I could explain this to a BCom graduate and they would understand as long as they understand the concepts of computing. So I asked it the question, what are the biggest challenges when it comes to artificial intelligence? And there are a number of challenges that it mentioned. The first one being lack of transparency. Lack of transparency essentially means deep learning models can be complex and difficult to interpret because it's a black box. You send in the data from one side, the outcome comes off the other side, and we don't know what happened when it comes to machine learning black boxes. There's bias and discrimination. AI systems can inadvertently perpetrate or amplify societal biases due to biased training data or algorithmic design. If we give it biased data, the outcome is also going to be biased. Privacy and security is another concern. Ethical dilemmas. AI technologies can pose ethical dilemmas, especially in decision-making contexts with significant consequences such as healthcare, law, or warfare. For example, how should an autonomous vehicle decide between saving its passengers? And this is one of the examples that was taken in that movie called iRobot, in which they've got these robots and the robot gets to decide who to save and who not to save based on the percentage probability of a person's survival, right? An ethical dilemma for an artificial intelligence system. A human being, we believe, would be able to decide better. And then computing power is another challenge. And, AI requires large amounts of computing power. Of course, we have large amounts of computing power, much better than what we had 20 years ago. But there's still a lot more to go. With the potential that we see in the future, the computing power is going to be a major challenge. So the next question that I asked is, how many of these AI challenges can be resolved using quantum computing? So the answer was interesting. First was error correction. Obviously, the environment is very sensitive at this point in time. We've still not made a lot of breakthrough when it comes to quantum computing. And these quantum computers can become a little more resilient, right? Once they've become more resilient, quantum computing can help improve accuracy and reliability of AI systems by using quantum error correction techniques such as encoding, decoding, syndrome measurement, etc. These techniques can protect the quantum information from noise and error caused by interactions with the environment. Right? Scalability. Quantum computing can help increase the scalability of AI systems by using quantum algorithms such as Grover's search or Shor's factoring or Haro-Hasidim-Lloyd linear system solver. Now, don't ask me what these are, and I will require a deeper study of what these are. But the point is that there are algorithms available that could help in scaling our artificial intelligence systems today. Hardware development. Quantum computing can help advance the hardware development of artificial intelligence. That's one of the challenges that artificial intelligence faces today. It doesn't have sufficient hardware, and what quantum computing does is it exponentially increases the power of the hardware. And then software development. Quantum computing can help enhance the software development of artificial intelligence systems by using quantum programming languages like Qiskit or Cirq or Q-sharp. Now, there are some challenges in artificial intelligence that cannot be solved by quantum computing. These are lack of transparency. Quantum computing cannot help explain how AI systems arrive at their decisions and outputs. As quantum systems are inherently probabilistic and complex, quantum computing may even increase the opacity and unpredictability of AI systems. So it might actually increase the challenge of lack of transparency. It cannot help us resolve bias and discrimination, obviously, because if we are giving it biased information, then it's going to give us an output that may also be biased. Privacy and security. Quantum computing cannot help protect the privacy of AI systems, as these issues are mainly related to data protection regulations and data handling practices. So they're more humane than they are technological. And then ethical dilemmas, again, are a human thing. They are more focused towards the liberal arts, and the liberal arts are essentially the study, and this goes back to Rome and Greece, medieval times, where they focused a lot on the study of logic and mathematics and language and ethics and morality and philosophy as well. And I think that we don't give sufficient focus on these liberal arts in our present day today. And there is going to come a time when these liberal arts are going to become more and more important for us. So these are not something that can be solved by quantum computing or anything. I mean, if an AI system faces an ethical dilemma, it is for us humans to explain it to them how it should resolve that ethical dilemma. So very, very interesting experiment. I also started doing a little bit of research on what people think about the roadmap of artificial intelligence in the future. Gartner happens to have a artificial intelligence maturity model, which basically gives the roadmap of how artificial intelligence is going to progress. At level 1, it's technology awareness, where we will become more technology aware. We will try to understand the technologies that help in creating artificial intelligence systems. And then we will move towards experimental activation of artificial intelligence, where we will start using artificial intelligence for various things like, MLOps, for example, machine learning operations, that will take care of systems, that will take care of error corrections, incident management, etc. within the organization, and various other things, large language model being one of the experimental uses of artificial intelligence. And then level 3 is the operationalization of artificial intelligence to innovate processes or products, right? We will start using artificial intelligence for innovations, like drug development in a pharmaceutical company, for example, right? Artificial intelligence systems can work on experiments that can come up with newer drugs, etc. And then level 4 is a systems approach and creation of new business models. Now, this is interesting because until level 3, what we are using artificial intelligence for is primarily for our purposes. We are taking artificial intelligence as a technology and using it for existing systems, right? Existing processes, existing businesses, existing innovations, etc. But when we get to level 4, we take our systems and from the ground up design them so that they can work with artificial intelligence, right? It's a systems approach to creating new business models that will inherently support artificial intelligence systems, right? From a scratch, first think about artificial intelligence and then build the systems accordingly, not the other way around. And then finally, we come to the future of AI, right? Future of AI, I would like to think of as a futuristic world where artificial intelligence has become so ubiquitous, so common, so all around us, that when we don't have AI, we miss it. For example, we're not surprised anymore. And this is an example that I read in one of the articles, and I'm going to post the link to the article in the show notes. When we use the mobile phone today, right, we're not surprised that we are able to connect with our friends. We're not surprised that we are able to receive phone calls and make phone calls. We're not surprised that we are able to connect to the internet to access whatever we want to, whatever information we want to. Becomes common. In fact, we are surprised when we are not able to do these things. Let's say we get stuck in an area where we don't have a very good connection, right? Or we run out of battery. We miss it. It becomes so part of our life that we miss it. Artificial intelligence is also going to become ubiquitous like that. And I would like to end with an example of Star Trek. I am a very big fan of Star Trek. And if you've seen Star Trek, you'll see that artificial intelligence is extremely ubiquitous in the Star Trek universe. For example, captain's log, personal log, they just start speaking and the computer starts taking a log, right? Captain's log, stardate 41153.7. Our destination is planet Deneb 4. Captain doesn't even have to tell him that please start recording a log. The computer knows. It's listening to you all the time. Or when one of the Star Trek members goes to the holodeck program and it says, computer, program the desired location, San Francisco, North America, Earth, time period, 1943 or whatever, right? Or when they walk into a turbolift and they just say decade, and the computer takes care of where the turbolift should be going. Or during an investigation, Commander Riker says, computer access all records of commander data and summarize. And the computer just does it. It just listens to what you're trying to say, understands it, and provides you with the information that you need. Trust me, a time like that is coming. And we will need to think about what we are going to be doing when that happens. Once again, I would like to remind you that Enterprise Architecture Radio is less a podcast and more a community. If you've not subscribed to Enterprise Architecture yet, please do so. If you like the content that I'm producing, share it with a friend or a colleague or a family member. If you don't like the content, let me know. If you would like me to cover some content that you find interesting, let me know. It's very easy for you to find us. We are all over the place. You can go to any social media, whether it's LinkedIn or Twitter or Telegram or, anything else, and just search for Enterprise Architecture Radio and you'll find us. We are there on all major podcast platforms. You can use any one of them. I hope you enjoyed this episode. Join the conversations. Talk, listen, learn, and of course, teach. Have fun.